Consider the function x squared minus 7x minus 18 over x squared plus 5x minus 6. Graph it in your graphing calculator on a standard window and draw a sketch. So take a minute here and put it in your graphing calculator. Make sure you use parentheses on the numerator and the denominator when putting it into your calculator, and pause the video here and draw your graph. So you should have gotten a graph that looks like this. So we're going to talk about how we got all of these points and how our graph looks like this. So first says factor the numerator and the denominator and then find the following. So let's factor this. So take a minute, pause the video and factor that out. Okay, so you should have gotten this, and I'm actually going to write it down here so that we can see it better. X plus 2, x minus 1, x plus 6. Okay, so we've got it factored now. So it says find the coordinates of the zeros. So our zeros are actually going to be in our numerator. So this tells us that our zeros are at x equals 9 and x equals negative 2. So we have that highlighted here. We've got negative 2 and we've got 9 right here. And then it says find the coordinates of the y-intercept. So if we were to plug in 0 into our function, we would get, so I'm going to do that right here, we would get 0 minus 18 over 0 plus 0 minus 6, which gives you negative 18 over negative 6, which y is equal to 3, which we get right here. So our y-intercept is 0, 3, and then our x-intercepts are 9, 0 and negative 2, 0. So now it says find the equation of the vertical asymptote. So our vertical asymptote is actually right here at negative 6 and right here at positive 1. And what do we notice about that? It's in our denominator. So our denominator tells us that our vertical asymptotes are at x equals 1 and x equals negative 6. Now to find a horizontal asymptote, we actually have rules for it. So our rules are based on the exponents of our graph. So here are our rules. Our rules for finding the horizontal asymptote. So we have some number a, x to the n, over some number b, x to the k. So n and our k are our exponents. So if n and k are equal, then this means that our horizontal asymptote will be the ratio of the two coefficients, so a over b. If n is less than k, then our horizontal asymptote is at 0. And if n is greater than k, then our graph has no horizontal asymptote. So let's take a look at what situation we have here. So we've got an x squared and an x squared, which means that we have this situation because 2 is equal to 2. So we have to find our a and our b, which there's nothing there, but we know that there's like an imaginary 1, which tells us that our horizontal asymptote is at y is equal to 1, which is right here. So this is what our graph looks like. So let's take a quick look at something here. Why did our graph, let's see, I'm going to erase some colors here so that you guys can see. Oops, my graph is gone. Yeah. Okay, I had a point here, and I have this. So why did my graph here cross, my middle graph cross the horizontal asymptote, but my left and my right side did not? And it's because our horizontal asymptote describes end behavior. And because of that, because we want to say as x is approaching negative infinity, that f of x is approaching 1. And we want to say as f of x is approaching, as x is approaching positive infinity, that f of x is again approaching 1. So we never wanted to cross that horizontal asymptote, otherwise our f of x would not be approaching 1. So our middle graph, it can cross, it doesn't have to, but we want it to because of our x-intercept right there. So we know that it has to cross in order to be like that. But our two side graphs, right, our side graphs are not going to look like this, because then as x is approaching negative infinity, f of x is then approaching negative infinity, and that's not what we want. We want it to approach 1. So our graph is going to look like this. Okay, so take a minute here, pause the video, and try to find the limits based on the graph we just drew. Okay, so this is what you should have gotten for your limits. Take a second here, pause the video, make sure you have all the right answers. Now flip over to the back. It says consider the function g of x is equal to x plus 3 over x squared plus 5x plus 4. So the first thing that we can do is we can find our y-intercept, right? If we plug in 0 for x, we get 0 plus 3 over 0 plus 0 plus 4, which gives you 3 over 4. So our y-intercept here is 0, 3/4. And we can find our x-intercepts. Our x-intercepts, remember, are in our numerator, which tells us that our x-intercept is going to be -3, 0. And our vertical asymptotes, remember, are in our denominator. So take a minute here, factor this out. Okay, so we get this. So our vertical asymptotes are going to be at x is equal to -1 and at x is equal to -4. So now we want to take a look at our horizontal asymptote. So remember that we're looking at our coefficients. So our coefficient here is 1 and our coefficient here is 2, which means that my n is less than my k, which tells me that my horizontal asymptote is at y is equal to 0. So this is my horizontal asymptote. Okay, so let's draw our graph. So we've got a y-intercept at 3/4, so this is 1. So let's say 3/4 is here. We've got an x-intercept at -3, and we have vertical asymptotes at -1 as well as at -4, and we've got a horizontal asymptote at 0. Okay, so let's take a look at what this is going to look like. Remember that our horizontal asymptote describes end behavior, so we want our ends to approach 0 but not touch 0, which means that our graph is not going to cross 0. And again over here as well. And this one is going to cross. Okay, so this is our graph. Our next one says consider the function h of x is equal to 2x squared minus x minus 1 over x minus 2. So let's find our y-intercept. When we plug in 0 for x, we get 0 minus 1 over 0 minus 2, which gives us negative 1 over negative 2, which is just a positive 1/2. So we have 0 comma 1/2. And our x-intercept is our numerator, so we want to factor this out. And pause the video here, take a second. Okay, so we've got our numerator here is this factored out, so our x-intercepts are going to be 2x plus 1 is equal to 0, which is 2x is equal to negative 1, so x is equal to negative 1/2. So we've got one intercept at 0 comma, negative 1/2 comma 0, and we've got x minus 1 is equal to 0, so x is equal to 1. So we've also got 1 comma 0. So now that we found those, we can look at our vertical asymptotes, which is in our denominator. There's nothing to factor there, so our vertical asymptote is just at x is equal to 2. In our horizontal asymptote, we have to look at our rules. So we see that n is equal to 2 and k is equal to 1, which means that our n is greater than our k, which tells us there is no horizontal asymptote. So let's draw our graph here. So we've got a y-intercept, say that's 1. We've got one at 0 comma 1/2. So here's our graph. So here's 1. So 0 comma 1/2. So we've got one right here. And then we have x-intercepts at negative 1/2. So let's say that's about here. And at 1 comma 0. And then we have a vertical asymptote at 2. Okay, so our graph looks like it's going to start from the bottom and go like this, so that it goes through all of our graphs, all of our points, sorry. And the other part of our graph is probably going to look something like this. So there's another concept that's coming. We haven't talked about it yet, but we'll be getting to it. It's called a slant asymptote, but pretty much it just means that we have like a symmetry going on. Sorry, this is a poorly drawn graph. But if it looks like this on one side, it should look like this on the other side. It'd be something like that. And you can also check this in your calculator. Take a minute here and plug this into your calculator. Don't forget, put parentheses around the numerator and the denominator, and check to make sure that this is what our graph looks like.